Okay, from here onwards, we're going to talk about the other part of chapter 3.2. So we started with the definition of the derivative as a function. We looked at how derivative as a function, and then we're going to build it up from there. And we did one example in the class. Now, we cannot find, I mean, it is so difficult or so cumbersome to do all this algebra and find the derivatives of functions using the original definition. Okay, it is so difficult. I mean, not difficult, but it takes time. So we don't want to do that over and over again, right? So you all the time, what you do, you write this f, if you want to find f prime of x, you do find the limit, h goes to 0, and then f of x plus h minus f of x divided by h, and then you substitute the function, and then you solve it a little bit and get the limit, and then you have f prime of x. Now, without doing that over and over again, what we do is we're going to find some equations, some basic elements, and some rules, so that we can use those things to find the derivatives of complex functions. Does that make sense? So what are these basic derivatives? Before introducing that, I would like to introduce a little bit of more notation. So we learned this f prime of x is the derivative of the function f of x. It can also be written as df over dx. Okay. df over df over dx is same as f prime of x. And it can also be written as y prime. Okay. And sometimes this is also equal to dy over dx, right? Because you write y equals fx sometimes, right? Y equals fx, right? And y is what? Y is dependent variable. X is the independent variable of function, right? And yeah, those are the notations that we're going to use. Okay. So we have first building block is to find the d of dx of c. C is a constant. What is the value of this one? It's 0. I mean, I can use the basic definition to prove that, but I'm not going to do it. I think we did once. We did it for the particular point. At all the a points for a constant function, derivative is 0. We obtained that previously, right? Does that make sense? And we obtained it for a linear function as well. And the second building block is this: d of dx x to the power n is equal to n times x to the power n minus 1. The proof is in the textbook. I'm not going to show the proof, right? So trivial. Proof is not important. Okay, proof is not important, but I can actually make a video and put it in the Brightspace, and you can watch it. And it is also in the book. If you want to read it, it's page number 135. Page number 135, the proof. Okay, proof. If you really want to learn it, let me know. I can explain it, right? I can explain it. But it's very self-explanatory in the book. You can look at it. So this n can be any real number. N can be any real number. How sweet is that, right? So now we can do a lot of functions, any polynomial function. Now we can find the derivative of any polynomial function. right? And later you're gonna learn, I don't know whether you learn this Taylor's expansion in pre-calculus. You learn Taylor's expansion in pre-calculus, you should have. Taylor series, Taylor expansion, you should have learned it. Don't remember that. Taylor's expansion is there in pre-calculus. So once you learn Taylor's expansion, probably, oh no, I don't think so. I don't think so. I'm sorry about that. I'm mistaken. I think it should be in later just because you need to know derivative to know the Taylor's expansion. But anyway, so once you learn that, right? Once you learn that, you can write any function pretty much using polynomials, using Taylor expansion. Or then you can derivate anything with that one. Okay. See how easy that. And I'm going to teach you some rules. The first rule is sum and difference rule. Sum and difference. Sum and difference rule. What is the sum and difference rule? You learn some sum and difference laws in limits, right? So what is that? If f and g are differentiable, so what does it mean by differentiable? Did we talk about this? Did we talk about the differentiability? What does it mean by differentiable? I think we talked about it. What is the differentiability? Why is some function is called differentiable? Can you click the notebook and see what is differentiable? Maybe talk about it. It's at the beginning of 3.2. 3. Is there something in the book related to that? Yeah. That's in the domain of methods. Right? So now if you define a function f of x, right, in the domain of that function, right? If f prime x exists, if f prime of x exists for all the value of x in the domain of f of x, then that function f is called differentiable, right? So what do you mean by existing the derivative? Existence of derivative depends on the existence of this limit, right? If this limit exists, what does that mean? That means the function is differentiable, right? Remember? And sometimes some cases are there that we learn about continuity, right? What should happen in the continuity? The limit, the right hand limit and the left hand limit should both exist. That means the limit should exist. And then the limit should be equal to the value of the function at that point. So that's called continuous. And if that happens throughout a range or interval or in the domain, right? That functions are called continuous function in that particular interval, right? So there are some nice things, right? Some if f is said differentiable if f prime of x exists for all x in the domain of x. And there's another thing. If the function is differentiable, there's another nice thing. I think I'm going to introduce that at the end, okay? I guess. Let me see. Yes. So now we said f and g are two differentiable functions. F and g are two differentiable functions. So then I can say, then f plus g prime f plus g, right? F plus g and f minus g are differentiable. And f plus g prime is equal to f prime plus g prime, and f minus g prime is equal to f prime and minus g prime. Okay. Now what you can do is you can add two functions and make a complex function. If those two functions are differentiable individually, their summation is also differentiable. And the summation, the derivative of the summation is equal to summation of the derivatives. Does that make sense? The derivative of summation is equal to the summation of the derivatives. And the difference, right? The derivative of the difference is equal to the differences in the of the derivatives. Right? You find the derivative and find the difference, right? And then constant multiple rule. Second one is the constant multiple rule. Constant multiple rule. If for any constant c, constant c of f is differentiable. Differentiable for any constant c, cf is differentiable. If f is differentiable, right? F should be differentiable, and cf prime is equal to c of c times f prime. Does that make sense? Any questions? These are easy. So few things that we need to remember. The derivative of constant is 0. And then you have this power function, any power of x, n times x to the power n minus 1. And then you have some rule and the constant multiple rule. Sounds good? Okay, let's do some problems. Nice, doing problems, right? Example. Any questions based on these things that I described? No? Good? Anything? Example 1. Okay, so the one is f of t is equal t cube minus 12t plus 4. Right? So you have to find the f prime t, right? Or so f prime t, or you can find d over dt ft, or df over dt, or you can write df over dt. Now t is the variable, right? So you have what? You can write the sum rule, right? Summation rule. you can write d over dt, right? T cube plus minus 12t plus 4. And you can write summation rule, according to summation rule, d over dt t cube minus d over dt 12t plus d over dt 4. Okay. And then this is what? What is the power rule? D over dt 3, it's like d over dx x to the power n. What is that? N times x to the power n minus 1. Right? So what is the derivative of the first term? Huh? 3t squared. Very good. 3t squared. And the second term, what is the constant multiple rule? D over dx c f. If you have this one, how do you write? C times d over dx f, right? So constant is 12 here. So what I can do is 12 times d over dt t. Does that make sense? Good. Plus, this is a constant. So what did you find? D over dx c. What is the answer for that one? Derivative of a constant is what? What is the derivative of the constant? Jason, what is the derivative of constant? One. If you flip the notebook back and see what we learned before, can you look at it? We just did it. What is 0? Yes. So why is that? If I show you graphically, a little bit of insight, okay? So how does a constant function look like? How does it look like graphically on this graph? On this graph, if it is f of x is a constant function c. How does it look like on this one? How do you draw a constant function on the graph?
Horizontal line.
Horizontal line. Great. I want people to talk. It's c, right? X equals c, right? So what is the slope of this line?
0.
0. So derivative of constant should be always 0. Okay? 0. Make sense? Good. Okay. Now we obtain this 3t squared minus 12. This is d over dtt. What is that? This looks like this, right? What is n in this case? What is n? This is exactly look like this, but what is n? N is equal to? This is t to the power what? T to the power 1, right? T to the power 1, right? So if you have 1, t to the power 1, how do you write? 1 times t to the power 1 minus 1. 1 minus 1 is 0. So that means t to the power 0. What is t to the power 0? Huh? What is x to the power 0?
1.
1. Power 0 for any number of any base is 1, not 0. It's 1. Very good. So you have what? Just 12. Does that make sense? Right? For if you have anything like d over dxx, what is the answer? What is d over dxx? What is d over dxx?
1.
1. Why is that? N is equal to 1, right? That means this is 1, x to the power 1 minus 1, x to the power 0. So that's equal to 1. Right? I'll show you something else. Again, graph. Go to the basic graph, right? So if you have a graph like that, y equals x. If fx equal to x, what is this? This is a linear or straight line that goes through 0, 0. What should be its derivative? Its slope is always constant, right? So your derivative should always be a constant, right? So let's say you have something like f of x equal k times x. K can be any number, right? If k is greater than 1, this is something like that. If k is less than 1, it's something like that. Right? So what is the derivative? What is the derivative? Derivative is always constant. So what is the derivative of this function? You should be able to say now. What is the derivative of this kx function? K. Very good. It's k. See that? This one what? 12t. So what is the derivative of that 12t function? Well, is that clear from the graph? Right? Okay, so this is our derivative. Does that make sense, guys? That's our derivative, d of dt, 3t squared minus 12. And I can actually find the derivative is equal to slope of the tangent line at any point t. Okay, so what is the, it asks us to find the values of t when tangent line is horizontal. The values of t where the tangent line is horizontal. Right. If the tangent line is horizontal, what is the value of derivative? We just talked about it. If the tangent line is horizontal, what is the value of derivative? 0. So wherever the point doesn't matter, right? Your derivative should be 0. So when the tangent line is horizontal, right? Take your notes. Horizontal derivative, right? df over dt should be 0. Now we want to find the values at which this df over dt equals 0. So how do you find that? You just make this df over dt 0. 3t squared minus 12 should be equal to 0. Right? Right? So how do I find the values where this becomes 0? Now we need to find the solutions of this equation. Right? How do I find the solutions of this equation? You can take 3 out from that, and then you have t squared minus 4 equal 0. Okay, which is t squared minus 4 equal 0. What is this? T squared minus 2 squared equals 0. Right? This is what? Difference of squares. How do I write this? Can anybody factor this? That? What is that? Is t squared? This is difference of squares. A squared minus B squared. How do I write that? Jason? Good. T minus 2 times T plus 2 equals 0. So T, either T minus 2 equal to 0 or T plus 2 equal to 0. The product, right? If the product of those two terms equal to 0, it either T minus 2 could be equal to 0 or T plus 2 equal to 0. Right? So T is equal to 2 or T is equal to negative 2. So either T equal to 2 or T equal to negative 2, the tangent line to the function is horizontal. Does that make sense to everybody? Derivative is easy. Differentiation is easy actually. Shall we do another one? Any questions from the previous? Okay, let's do another one. And I'm going slow. I'm going slow because I want you to understand this, okay? Example 2. And you can ask me any question. G of t is equal to t to the power negative 3 plus 2 times square root of t, right? Minus t to the power negative 4/5. Find dg over dt at t equals 1. So we want to find d over dtg at t equals 1. Basically, derivative at t equals 1. So we want to find a general derivative as a function, and then we're going to substitute t equals 1. That's what our plan is. So let's find this dg over dt. I'll give you a couple of minutes to look at this, and then to come up with the method to find this. Okay, you can use your rules and then the other theorems or whatever building blocks that we learned. Find this. Okay. Hope you started doing it. Thinking about the problem. We're still sharing. Oh, I'm not sharing. see what happened. Share. Citlali, do you see my screen now?
Yes.
Okay. Okay, so let's just make sure that it's recording. Yes, it's recording. Let's do that. So I'm going to use sum rule here. Okay. So I can use d over dt, t to the power -3 plus d over dt, 2 times square root of t minus d over dt, 2 to the t to the power -4/5. Make sense? That's the sum rule. And then we're going to use this, right? This is a great tool. As I said, you can do any polynomial. X to the power n is equal to n times x to the power n minus 1. Never ever forget this, right? If you're doing engineering, you're going to be using this over and over again, right? Connor, I do not remember a particular example in biology, but if you're doing some population growth or something like that, I think you will face with some kind of differential equations. So you get some of these, right? That might be the case that you need to do Cal 1. Okay, we'll see that. I'll see whether I can find some examples from your discipline. Okay, so I can find tons of examples in engineering. So, and then this is what -3. We're gonna talk more about examples later on, right? The practical examples. N is equal to -3, right? So put -3, t to the power -3 minus 1, -4. Good, right? That's okay. Plus, it's good. 2 times. This is half, right? T to the power half. D over dt. T to the power half. Square root is power half. Okay. Minus, now this one, -4/5 times t to the power -4/5 minus 1. Okay. And here it's -3 t to the power -4, right? Plus 2 times, this is n is half, right? Half times t to the power half minus 1. Okay. Minus negative, so you have negative value here. So what we can do is multiply negative and it becomes positive. Does that make sense? So I'm positive 4/5, and this is t to the power what? -9/5. Right? Right? 1 is 5/5. 5/5. Right? So it's divided plus 4/5. This is -9/5. Make sense? Okay. So now we can write -3 t to the power -4 plus half times 2 is 1, right? T to the power -half plus 4/5 t to the power -9/5. This is your G prime T, or you can also write dg over dt. So our solution, what we need to find is dg over dt at t equals 1. So what would I do? What would I do to find that?
Plug it in.
What? Plug it in, yes, you substitute t equals 1 for all t values in that equation. So you have -3, 1 to the power -4 plus t is 1 again, 1 times power of half plus 4/5 t to the, sorry, t, instead of t, you put 1, -9/5. Right? So you have, this is -3, right? Because any power of 1 is equal to 1. Plus 1, right? Plus 4/5. Now you can solve it. Your common denominator is 5. So you have 15 plus 5, -10, -6. Right? Is that right? This is right. We are out of time. So